Hi guys, this section is about polynomials and function notation, and then we kind of get into the fundamental theorem of algebra. So on these first ones, you're just reviewing function notation. So we want you to know that that 2, that means x equals 2. That's what that means. And we want to input, this is an input value, in for x. Everywhere there's an x, we want to put that 2. And we're just going to simplify it down. So I have negative 2 to the third, minus 10, 2 squared, plus 26 times 2, plus 25. So basically everywhere there was an x, I put a 2. And now we're going to just simplify this. So negative 2, and then 2 to the third becomes 8. Minus 10, 2 squared is 4. Plus 26 times 2 is 52. Plus 25. And then I'm just going to keep going. Negative 16 minus 40 plus, and this becomes 77. Negative 16 minus 40, we can add those together, so they become negative 56 plus 77. So remember, same sign, add, different sign, subtract. So I'm going to take 77 minus 56, and we get 21. So that is our answer. We're just getting it down to one number. And that number, it's our output value. We're not always going to be using numbers though. For this particular example, we're looking at inserting the function x plus 1 in for x. So a function within a function. But it's the same concept. Everywhere I have an x, I'm going to put x plus 1, sorry. So negative 4, but instead of x, I'm going to have x plus 1 cubed. Plus 20, but instead of x, it's x plus 1. Plus 4, x plus 1. No, plus, I almost wrote plus there. And then minus 1. So it's the same function, but I replaced all the x's with x plus 1. So this requires a lot of simplifying. So we know that x plus 1 cubed, that's really x plus 1 times x plus 1 times x plus 1. That's a lot. We cannot just distribute. That's not okay. We have to multiply it by itself 3 times. And same thing on our next term. This is really x plus 1 times x plus 1. And then 4x plus 1 minus 1. So this is a lot of simplifying. Let's start with x plus 1 squared. So that is x times x squared plus x plus 1. So x squared plus 2x plus 1. So I'm just going to rewrite that part. So on this first one, I still have negative 4. I still have an x plus 1. But instead of these, I have x squared plus 2x plus 1. And I'm going to rewrite the second term, which is plus 20. But instead of those, it's x squared plus 2x plus 1. And I'm going to simplify this while we're here. So plus 4x plus 4 minus 1. Alright. So now I have to multiply this binomial and trinomial. So I'm going to multiply x by all three of those terms. So I get x cubed plus 2x squared plus x. And then I'm going to multiply the 1 all the way through. So 1 and x squared, I'm going to write these stacked so I can combine my like terms. So x squared, 1 times 2x is 2x, 1 times 1 is 1. And when we combine those, we still have the negative 4, but then this whole term becomes x cubed plus 3x squared plus 3x plus 1. And then I'm going to simplify this by distributing the 20. So plus 20x squared plus 40x plus 20 plus 4x, and then this becomes plus 3. Whew. Okay, we're almost there. Now we have to distribute the negative 4 all the way across, and then we can combine some like terms out here. So let's do that. So I have negative 4x cubed minus 12x squared minus 12x minus 4. The 20x squared doesn't have anything to combine with. But I have 40x plus 4x, so I'm going to write plus 44x. And I have 20 and 3, so plus 23. And the last step is just to combine my like terms. So I only have one term with x cubed, so negative 4x cubed. Now I'm going to look for all my x squareds. So I have negative 12 plus 20, so that gives me 8x squared. And then I have my x's, so negative 12 plus 44, that gives me 22. Am I struggling with that? 32. 32x. And then negative 4 plus 23 is plus 19. So when I go look at my answers, I can see this final one right here. So a lot of this, guys, as you can see, is just the algebra. It's combining the like terms, it's the multiplying binomials, trinomials, but you're just trying to get it down. So there's an x cubed, x squared, x. Okay, and the last type of question you'll see, this is about the fundamental theorem of algebra. So when you have a polynomial and you're looking for the largest degree, what degree polynomial is this? This is a polynomial which we would call degree 5 because the largest exponent is 5. So that one. We call this also a quintic. So if it's x squared, it's a quadratic. If it's x cubed, it's a cubic. X to the 4th is quartic. X to the 5th is quintic. So that's a quintic. And then this 5 also tells us that we have 5 possible answers. 5 possible real zeros. Okay, that's what the fundamental theorem of algebra is. You look at the degree, those are your possible answers. Okay, And that's it for this section. So if you have questions or if you want to go over more of these, ask me or Miss